Hello everyone, this is Rick Morgan. I'm going to talk a little bit about James Clerk Maxwell. It's possibly the third greatest scientist who ever lived behind Einstein and Newton. Well, he is, just is. Amazing man. Richard Feynman himself in the 1960s said that we will someday remember the 19th century as the century that produced James Clerk Maxwell, and not for things like the American Civil War, other things that happened historically, because this guy was bonkers smart and a genius. He grew up near Edinburgh. He was just incredibly brilliant, one of those rare minds that comes around once a century maybe. What did he do? I'm going to read you a little bit of the things he did here from this website and then show you some places that he lived and worked. So some things you might think of. He discovered, just a quick brief one if you want to skip forward after this, he's the guy who figured out that electricity, magnetism, and light all came from the same fundamental force. He made the first color photograph. He developed systems of built trusses that hold bridges up we know today, discovered what held Saturn's rings together and what they were made out of. He discovered the kinetic molecular theory of gases. He applied the math to all of his really awesome equations to all the Faraday's work in electrochemistry earlier. He put the math to all that stuff. Like, he just did a lot, right? So I'll read a few things here. It says, Clerk Maxwell is rightly remembered as one of the most inventive and influential physicists of all time. He was born in Edinburgh and spent most of his childhood years in southwest Scotland. You should also know that this guy had an insatiable curiosity. He was constantly asking his parents, what's the go of this? What's the go of that? And I can't do the Scottish accent, but you can get it. Remember the kinetic theory of gases that led to the ideal gas law? Boom, this guy. Wikipedia lists him as, the list of things that they list for him of having discovered is humongous. So check this out. Let's see. What is he known for? Oh, I don't know. Statistical mechanics, Maxwell's equations, displacement current Maxwell relations, Maxwell-Boson distribution, statistics, Maxwell-Stefan diffusion, Maxwell's demon, Maxwell construction, Maxwell's theorem, all this kind of stuff, right? All this crazy thing. We're talking kinetic molecular theory of gases, everything, all kinds of stuff, not even counting his regular inventions. And then what was he influenced? What did he influence? Influences these people, influenced virtually all subsequent physics. Dude, I mean, come on. So there's this web page, homepages.abdn.ac.uk. It's an Aberdeen web page, but he ended up teaching at Cambridge, of course, and at Aberdeen University. But what are some of the things he did when it comes to Aberdeen? Well, 1856, he's teaching at the college, worked on his Saturn rings papers. Looks like I might have to cut some of this. So he's appointed professor of natural philosophy, which was what they called science or physics back then, at Marshall College, which is literally right out my window here. In 1856, he wanted to teach mechanics, optics, and astronomy. So he eventually got pushed out of there. Then he lived at 129 Union Street. This is what his house looked like back then in the 19th century. It looks pretty similar today. And he was teaching here at Aberdeen. He ran an evening class for workers. Now get it, not for back then they didn't teach just workers regular stuff, right? At the Aberdeen School of Science, he worked on fundamental problems in light, understanding light, the behavior of gases, and astronomy. He married a principal's daughter, which her name was Dewar. Think of the dewars that you put liquid nitrogen in. He left Aberdeen in 1860. He got a royal commission after the two universities merged, and he was promoted. He worked at King's College. So he was here for a while teaching these things. Now he invented here, because I'm in Aberdeen right now. So he discovered a lot of stuff there, but let's see what some other stuff. Well, here's some things he did with color science. He showed how to measure color. Like, he had a colorimeter that measured what colors are. He showed to measure color blindness. He showed the color photograph could be made. He made the first color photograph of a tartan. I saw it today or yesterday. So he made a top. The top is different than these, but he played with tops as a kid, and he would spin them and make colors. You can read some of this later, but here's a picture of this tartan that it was around his neck. And he took a full color picture of a scarf. I'm not going to go over it in detail because you can read this yourself. Some of the other things he did were Oh, there's his actual top that he used, by the way. So he was fond of spinning toys and tops. He used it to solve the problems of Saturn's rings. He would spin this little device here with these little balls on it to show he proved how Saturn's rings must be made of little pieces of ice and they're floating apart. So he wanted to think about molecules, and he developed the kinetic molecular theory of gases, from which we built the ideal gas law. Well, it was built from a lot of different smaller relationships too, but this showed how it worked, because there was also Boyle's law and the law of Gay-Lussac and stuff. But he put this all together in a ground up, not a top down like experimental theory, like how these things work, but basically built it up from the molecular side. So yeah, the dynamic theory of gases in 1859, he treated gas as a collection of molecules that moved about as random, colliding with each other, which ended up working. It was a novel idea in his day. He had the Maxwell distribution of speeds of gas. He was able to calculate given a temperature, what is the distribution of the speeds of gas molecules? Huge deal, especially in physical chemistry. By the way, one of his colleagues and teachers was Lord Kelvin, the guy who came up with the Carnot cycle and all the heat stuff and the Kelvin temperature. At first, Maxwell's ideas were considered interesting but unproven. He had deduced that the viscosity of a gas should be independent of pressure, which didn't seem plausible, but it is. So all kinds of stuff. I get that I'm gushing a little bit here and maybe getting boring, but a lot of stuff he gave us the idea of so many things, and so much of it's beyond an introductory class in chemistry. But oh yeah, by the way, field lines, why should these lines not go straight? Why should they curve out like this in electrical field from magnets and from like electroplating and things? Well, Faraday knew that this was happening. It was his idea, but Maxwell put math to it. And so Faraday discovered electromagnetic induction, electrochemistry, how to make simple electric motor, and more. Faraday tried to understand his result with the concept of lines of magnetic force, but it was Maxwell who put math to it. Maxwell turned Faraday's ideas into the electric field symbols E and D and magnetic field symbols H and B, and realized that the fields were fundamental realities of electricity and magnetism, being the same thing. His theory had its 4 basic equations, was the first ever field theory in physics. Pretty cool, right? Following Maxwell and the experimental work of Heinrich Hertz, Marconi's 215-foot wooden aerial towers at Poldhu, Cornwall, inaugurated transatlantic radio in 1901. Like all these stuff that this guy did. Like this is a big one here, electric and magnetic fields. Here's some of his equations here, Maxwell's equations. So, he was responsible. Basically, he predicted that radio waves would be possible before anybody made them, and they could be used to communicate. Like he knew this back in the 1860s or 1850s. So Maxwell's legacy, Scotland's greatest science. Einstein acknowledged that in many ways he drew his inspiration from Maxwell. One of the few pictures hanging on his office was of Maxwell. Einstein's general theory of relativity, published in 1916, was the first of the 20th century's field theories, inspired by Maxwell's electromagnetic field theory, and redefined reality. So there's just a lot of stuff going on. I'll let you read these things yourself if you want. This is on George Street in Edinburgh. I saw that today, a statue of him. So you can look more up yourself, but he died at the age of 48. I'm 51 now. This guy died 3 years younger than me now. So pretty awesome, I'd say. So continue watching the video if you're interested. I hope you enjoyed. Take care. Bye-bye. James Clerk Maxwell was born here, number 14 India Street. Reads here, James Clerk Maxwell, born here 13 June 1831. And this is his house. That's his home. Here's a view of the area surrounding it, looked like, which probably looked just like this 200 years ago. Well, minus the cars, I suspect. But wow, huh? Isn't that something? It is really something to see. And I'm really in awe to have seen this place. It's pretty cool. I love it so much. In 1855, James Clerk Maxwell was 24 years old, and he got a job being a professor, not just a professor, but the headmaster, or lead professor here at Marshall College in Aberdeen, where this is where he did a lot of his work on Saturn's rings and continues work on mixing colors, and became a molecular scientist and developed the kinetic theory of gases, which led up to the ideal gas law. Like, he did a lot of stuff, and so he ended up, he taught here at Marshall College in Aberdeen. 24 years old, was a professor and the lead professor. I'm about to go into Provost Skane's house here, and this is a treat for anyone who likes science. And if we're talking about James Clerk Maxwell, this is that, like, since I'm an electrochemist, this is right up there with stuff I would like Faraday. This is the guy that put math to Faraday's experiments. So for me, this is just a little bit of slice of heaven, and we're going to see some of his stuff in here. Some more James Clerk Maxwell stuff. So this reads, James Clerk Maxwell's theory of Saturn's rings. When he was in Aberdeen, Maxwell began to study the arrangement of the planet Saturn's rings. Scientists could not understand why the rings did not crash into or move away from the planet. In 1859, James published his detailed essay on the stability and motion of Saturn's rings, in which he argued that Saturn's rings consist of concentric rings of satellites made of small solid particles. To prove this theory was mechanically possible, he created a model using two parallel wheels attached to a crank handle. Attached to one of the wheels were satellites that turned in circular motion as the axle rotated, demonstrating the wave patterns of satellites and rings. There's a description of his model here. You can see it. Prior to James's theory, scientists believed Saturn's rings were either fluid or solid circles. His theory on Saturn was confirmed 100 years later when the Voyager space probe took photographs of Saturn. Look up to see a model. So here we go. Up above here, we're going to push the button, and you're going to see something happen here. Let's just see I guess there's not really much going on, but that's pretty cool still. So James Clerk Maxwell actually lived right here at 129 Union Street, right up from this Taco Bell over here and McDonald's, across from St. Nicholas Kirk. And this is Union Street in general. And here's the building he lived in. And I'll show you in a moment the little plaque here on the wall that shows where he lived. Pioneering physicist of electromagnetic radiation, molecular science, which is kinetic gas law, colorimetry, a lot of other things too. Lived in this building from 1856 to 1860 while professor at Marshall College, later at the University of Aberdeen. He actually took the first color photograph as well. He took one of a tartan. I think this is an image of it, and he used 3 color filters to gels to expose the different colors, and he was able to make the first color photograph. That's an example of it there. His actual color wheels here, you can see. Obviously the top part isn't original, but the rest is Maxwell's actual color wheel. Incredible. So incredible. And look how the little adjustments he made to make it exactly level.